Hi, good evening, sir. Let me introduce myself to you. My name is N. Sandeep. I am from Mechanical Engineering. Today, my topic is about dimensional homogeneity. Introduction to dimensional homogeneity. Dimensional homogeneity refers to the principle that equation must be consistent in their dimensions. It ensures that the terms in a equation can be combined meaningfully. This concept is fundamental in physics and engineering to maintain the ingenuity of mathematical models. This diagrams are shows about dimensional analysis. Force formula force M1 L1 T minus 2, density formula M1 L minus 3 T0, velocity M0 L1 T minus 1. Importance in physics. Dimensional homogeneity is crucial for driving physical laws of equations. It helps in identify errors in mathematical formulation and calculations. By ensuring dimensional consistency, we can validate the relationship between different physical quantities. Formulas for physics: acceleration, momentum, force, pressure. Acceleration formula: velocity by time. Momentum formula: mass into velocity. Force is equal to mass into acceleration. Pressure is equal to force by area. Again, if is equal to LT minus 1 by T is equal to M0 LT minus 2. Momentum m into L t minus 1 is equal to ml t minus 1. Force is equal to m into L t minus 2 is equal to ml t minus 2. Pressure m L t minus 2 by L2 is equal to ml minus t minus 2. Fundamental dimensions. There are seven fundamental dimensions in physics: length, mass, time, velocity, current, temperature, amount, substance, and luminosity intensity. Each physical quantity can be expressed in terms of fundamental dimension. Understanding these dimensions helps in checking the homogeneity of equation. The SI specific seven fundamental measures: length, mass, time, electric current, temperature, amount of suspension, and luminosity intensity. Dimension analysis. Dimension analysis is the method used to verify the dimensional homogeneity of equations. It involves breaking down quantities into their fundamental dimension to ensure consistency. This technique can also be used to derive the relation between different physical quantities. This by throwing a ball into upway, the velocity formula is equal to R is equal to V naught square sine 2 theta by gravity. Terms of dimension homogeneity. The equation for force F is equal to M. A is a dimensional homogeneous because both sides can expand in terms of mass and acceleration. In contrast, an equation like V is equal to D plus T is not dimensionally homogeneous since the units do not match. Which one of the following equation is dimensional homogeneous? So you have proof. F is equal to MA, F is equal to M is square by R, F into T2 minus T1 is equal to M into V2 minus V1. F is equal to MV, F is equal to M into M by V2 minus V1 by T2 minus T1, where F is equal to force, M is equal to mass, A is equal to acceleration, V is equal to velocity, R is equal to radius, T is equal to time. Application in engineering. Engineers use dimensional homogeneity to design system and analyze structure reliability. It helps in simplifying complex equations by reducing them to their fundamental dimensions. This practice ensures the accurate and efficiency of engineering calculation. D is equal to D naught plus V naught T plus 1 of 8 is 5. Homogeneous equation. L is equal to L plus L by T, T plus L by T square into T square. L is equal to L plus L plus L. Dimension homogeneous. Common mistakes. A frequent mistake is neglecting units which performing calculation leading to incorrect results. Another common error is mixing different units without proper convention, compromising dimension consistency. Understanding dimension homogeneity helps avoid these pitfalls in scientific and engineering work. Dimensional homogeneity in software. Many engineering software tools incorporate check for dimensional homogeneity in their algorithms. These checks help user identify error because finalizing design or simulation. Incorporating dimension analysis in software, engine reliability and users comfort. D is equal to D naught plus V naught T plus of 80 square. Homogeneous equation. L is equal to L plus L by T into T by L by T square T square. L is equal to L plus L plus L. Dimension homogeneous. Limitation of dimensional analysis. Dimensional analysis cannot provide numerical confidence constants in equations. It also cannot account for the underlying physics or phenomena that govern the relationship between variables. Despite this limitation, it remains a powerful tool for validating and simplifying equation. Areas. Area is equal to length into breadth is equal to L into L is equal to L square is equal to M naught L square T naught. Volume is equal to length into breadth into height is equal to L into L into L is equal to L cube is equal to M naught L cube T naught. Density is equal to mass by volume. M by L cube is equal to into ml minus 3 t naught into speed of velocity distance by time. L by t is equal to m naught L t minus 1. Conclusion. Dimensional homogeneity is a critical concept in ensuring the validity of scientific equation. By adhering to principles, scientists and engineers can avoid errors and engineer the accuracy of this work. Unlimited, a solid understanding of dimensional analysis foster better problem solving in various fields. Thank you so much, sir, for giving this opportunity. Thank you, sir.